Good morning. The name of this study is Water Use in University Restaurants, a case study in Goiânia, and the authors are Luiz Felipe, Thalita Vieira, and Marcos André Siqueira Campos. Water scarcity today affects 1 in every 3 inhabitants on the planet. In this scenario, the efforts of universities around the world to study ways to rationalize the use of water stand out. At Federal University of Goiás, a growing focus has been given to water consumption in university restaurants, RU. These restaurants are part of the federal government assistance system, which aims to provide low-cost meals to the academic community, thus reducing the dropout rate. Restaurants are considered to be major consumers of water. This evaluation is made by the consumption indicator, CI, of restaurants, and to calculate it, it is necessary to consider the typology of the building, since these values can vary. A common value in the literature is 25 liters per meal. The highest water consumption in a restaurant is associated with activities developed in the kitchen, followed by the domestic activities, as it can be seen in this figure. Out of the activities carried out in the kitchen, a study by Nogueira in industrial kitchens showed that the activity that consumes the most water is the washing of utensils. Next comes food hygiene, and together these two activities account for more than 90% of the kitchen's consumption. Just as it was done by Nogueira, this work has the objective of estimating the water consumption of university restaurants, with a case study in the RU of Campus 1 of UFG. This type of restaurant is still little explored in the literature, represents one of the biggest consumptions of Campus 1. This study was divided into 4 stages. The first stage was to choose and characterize the study case. Campus 1 of UFG is located in Goiânia and has 5 blocks. The RU is located in block 71 and is highlighted in the figure. According to data from the university, this block represents approximately 60% of the water consumption of this campus. The number of meals served in 2018 was 319,088. However, the distribution was not uniform throughout the year. This phenomenon can be explained by the academic calendar. The months of lowest consumption, that is, January, February, July, and December, correspond to the undergraduate students' vacation, and because of that, during these periods, consumption is reduced. At the stage of preparation and application of data collection instruments, a questionnaire was designed to facilitate the collection of information. This questionnaire was designed to both the responsible nutritionist and the workers. The questions were about the process, the time of execution, and the frequency. To validate the information, in addition to the questionnaire applied, the activities were observed with a stopwatch and a container with a known volume. This data collection was made during 4 technical visits, all of them after lunch. As there is no water meter for individual measurements in the RU, it was only possible to make estimates of consumption. Activities carried out in the kitchen were divided into 4 categories. For the food hygiene activity, this estimate was made based on information provided by the nutritionist. For the preparation activity, information provided by the workers and data from the manufacturers of the pans were used. In the washing activities, this estimate was made by measuring the flow rate of the tap and estimating a washing time based on information provided by the worker. Also, when applied, it was necessary to consult the volume of water consumed per cycle of the washing machine. Finally, the estimate of water consumption of the floor cleaning activity was done based on information provided by the nutritionist, and the volume of water consumed in this activity was calculated. In the step of data processing and analysis, the data obtained with the questionnaire and observations were treated. The water consumption of the activities carried out in the RU and the calculated CI value were compared with the value expected by the literature. To find the CI value, the number of meals served in the month of October 2019 was considered to be the same as in October 2018. The results are presented here according to the 4 activities developed in the RU. The hygiene process consists firstly of washing fruits, vegetables, and leaves under running water. Then, these foods are soaked in sodium hypochlorite solution and then rinsed again under running water. Fruits, vegetables, and greens go through a single soak, while leaves go through 3. To estimate the volume consumed in soaks, it was necessary to calculate the number of bowls used. This was obtained by the amount of food served daily, the average density of the food, and the volume occupied by the food in the bowl. The bowls used had a capacity of 40 liters, half of which was considered to be filled by food and half by water. For the volume consumed in the rinse stage, the flow rate of the tap was measured to be 0.14 liters per second. The rinsing times are standardized and are shown in the table below, already considering the first and the second rinse. The amount of water consumed daily is shown in the table. In the activity of food preparation, The only water used in breakfast is in the preparation of coffee, with and without sugar, and tea. Each bottle has a capacity of 12 liters and is served only once a day. On weekends, the same amount is served. The amount of water used in preparation of food was calculated based on information provided by the nutritionist. The juice is served in the concentrated form in gallons of 5 liters and in a proportion of 1 gallon of juice to 6 gallons of water. 7 gallons of juice are used during lunch. For dinner, a proportion was made between dinner and lunch served in 2018 to estimate the volume of water consumed at dinner. This proportion was found to be 30%. He was informed by the nutritionist that the consumption on Saturdays is similar to the consumption of dinner, and therefore, this proportion was used to calculate the volume of water consumed on Saturday. The volume of water consumed in this activity per week is shown in the table. Utensils hygiene was divided in three. The first one was the pan washing. The pans are washed under running water in a tap with a flow rate of 0.2 liters per second. Based on the observations made during the visits, it was found that the tap is open for a total of 9 minutes over 1 hour, which corresponds to the proportion of 15% of the hour. A workload of 8 hours during weekdays and 4 hours during Saturdays was considered. This 8 hours estimate was validated by the workers. The volume of water consumed for this activity per week is shown in the table. The washing of the tray is done in two stages. First, they are washed in running water with a tap with a flow rate of 0.17 liters per second. This tap is open without interruption during the washing of the trays. Then, these trays are washed in a machine. The tap was considered to be open from 11 a.m. to 3 p.m. for lunch. For dinner and for Saturdays, it was considered the water consumption was 30% that of lunch. For breakfast, this proportion was 2%. The machine has the capacity to wash 9 trays simultaneously and consume 2.4 liters per cycle. The number of meals served in the month of October 2018 is shown in the table. The volume of water consumed in this activity is also shown in the table. The cutlery washing is done exclusively in the machine. The number of cutlery was considered to be double the number of meals served in October. Each machine has a capacity of 240 cutlery, according to the manufacturer. The workers reported that each cutlery goes through 3 cycles. The volume of water consumed per cycle is 2.4 liters. The volume of water consumed for this activity is also shown in the table. The floor cleaning activity varies in frequency and in the way the washing is done, depending on the environment. In some, washing is done with a soap and water, and in others it can be also done with a wet cloth. The washing frequency was provided by the nutritionist. The volume consumed was given in liters per week. The volume of water consumed for this activity in a week, considering both ways of cleaning, was 3,635 liters, approximately. The activity that represented the highest water consumption in the RU was the cleaning of utensils, followed by the activity of food preparation. Together, they represent more than 70% of the restaurant's water consumption. As for utensils hygiene, the higher consumption was already expected because the same behavior was seen in other studies. However, regarding the activity of food preparation, this value was not expected, and can be explained mainly by the fact that pressure cookers are not used during the cooking of grains and beans, which increases water consumption. The lowest water consumption activities were the food hygiene, followed by the floor cleaning activity. The consumption indicator value found for the restaurant was 8.7 liters per meal. This indicator value differs significantly from the standard literature value of 25 liters per meal. Even though values of the same magnitude were already found for the same typology, one can think of reasons that made this value so different. The first reason that may have caused this difference is the simplicity of the foods served. Unlike other restaurants, the RU has a fixed menu that varies very little over the weeks. Another reason that might explain this difference is that the RU is not washed with water as often as other restaurants. To conclude, in order to reduce water consumption in the RU, it is necessary to study its consumption patterns. The indicator value calculated shows the difference in the water consumption pattern of this typology of restaurants in comparison to other restaurants. Characterizing the consumption of water in this specific type of restaurant is important not only because it can contribute with data to the literature, but also because it allows the creation of action plans aimed to reduce water consumption and its costs. This reduction would make it possible to make better use of the money saved and distribute the water to other users more fairly, thus contributing to the preservation of the environment and universal access to water. Thank you.